Hi, I'm Luca. I'm a PhD student based in Munich at TU Munich, and I work on generative modeling, diffusion and flow matching models. And in particular, I've been thinking a lot about if you generate some images, for example, with a diffusion model, then you enter a text and you would like an image that has the elements that you specify in this text, and you get a few different images that are kind of, you don't control the rest of what's happening there. So usually these current kind of models, they give you, let's say, 4 different options kind of for your text. There's a reason why we have this diversity and this different kind of 4 different images that are being generated. And I've been thinking a lot about how can we better understand this specific part of image generation model and learn to control, manipulate, and interpret that better, such that we can better control image generation apart from kind of just picking the image we like most for our given prompt.
Why is it important that we understand what's going on behind the scenes?
I think as these models are used more and more, as we move them to video generation, the first argument is the safety concerns that we have, when we can't control everything that is being generated, when you can't really understand, there's a possibility that these models can be hacked, they can be used to generate unsafe contents, exactly through this kind of diversity that we don't understand, because we only kind of have control over the text and not about the noise part in diffusion models. And then we do post-filtering, we filter out any image that is not safe, but ideally we would prevent this from the start, right? So yeah, this is one of the main concerns.
Any general thoughts then about AI safety and technical research for that?
Yeah, I think it's super important. The problem with this AI safety research is a bit that as models get larger and larger, and the interpretability research is also moving with that, but is lacking behind a bit always. That's what I feel like, at least. And I think it's important to also think about not just kind of the very fundamental interpretability research, but also a realistic view of this, given these larger models. What actually can we do for these huge models that can give us something? It might not be perfect, but it's better than just trying out these very fundamental things that don't scale up and we kind of can't apply them to these large models.
Totally. What got you interested in diffusion models in the first place?
That's a good question. I think they're cool. First up, you can use them to generate nice looking images. And secondly, I would also consider myself a theory person, and there's cool theory that you can do with diffusion models. They're based on kind of math and theory, which makes it more fun for me to work on. I try to work on just what is fun for me.
What are you looking forward to working on then next year?
My vision of kind of an image generative model is that we have the text conditioning, but then we also can control the rest of the diversity. So for example, if we want to generate a photo of a dog in front of the Eiffel Tower, or let's say in San Diego, then there's a bunch of things that kind of could look very differently. It could be at the beach in San Diego, it could be in the city center, there could be some skyline. And ideally, we can control these elements in a way where for example, we would have some automatic sliders that we can kind of control, and we can kind of slide them left and right. And these sliders tell us how they have different meanings, and we can kind of in an unsupervised way control the image that is being generated and going further than just a prompt. And currently what you can do is you can add more details to your prompt. So you add more and more details, but this doesn't really work the way we would want it, because the diversity still remains. We still get different images, and it's just a very fundamental part of these models that, in my opinion, is currently treated as a random variable, while it shouldn't be, because it is something that matters, and we should try to make it as controllable as possible. And I'm excited to push towards that. Maybe not solve it completely, but take smaller and smaller steps. This is what research is all about. We don't solve problems in a single step usually. We do kind of iterations and do small steps towards a goal, and at some point we're getting there, hopefully.
What are some applications of your research that you're most excited about in industry or in the real world?
So in the last year, I've been working a lot on reward alignment. The theme that has emerged for actually all kinds of applications in machine learning is we pre-train some large model that is able to generate a very diverse distribution of language or image or proteins, for example. And then in a second step, we do so-called post-training, where we try to steer the model towards what we really care about. So for images, we want these aesthetic looking images that humans think are nice to look at. For language, we want the models to be able to reason better, safety kind of alignment things we want to integrate there. And then I think in the sciences, there's some very exciting applications for post-training, where, for example, for proteins, we want to be able to generate proteins with certain properties. And the thing there is that actually, if you just generate one protein with the properties we want, this would already be a breakthrough. So this is a bit different for if you generate a very aesthetic looking image. Well, it's nice, but not that many people will care about it. While in biology, in protein generation, or also in RNA generation, getting these models really controllable and pushing the controllability with certain rewards, so for certain aspects of proteins that you care about, I think that is quite exciting, and it can unlock new potentials of proteins and RNAs.
How quickly do you think that will arrive, that kind of progress in protein and RNA research?
I think it's very data dependent. So it depends on the application area and how much data is available for the property that you care about. For RNA, you might want to maximize protein expression, so how much protein is being generated after you ingest this RNA into the body. And there is not that much public data available on that, so this means it's a bit harder to solve that problem. But for anything where we already have public data available, or maybe some company has internal data available, I think it will actually move quite quickly, because this theme that I was just explaining has shown to work across all these applications, and there's no reason that it shouldn't work next year on a certain property of proteins, for example.
Are you looking forward to next year?
Yes.
Amazing. Any other predictions you want to share about the future of AI?
So currently, discrete diffusion models have gotten a lot more popular for language generation, and people are excited about them. I think mainly because it's the new thing, and people are usually excited to work on a new thing. In my view, the potential of discrete diffusion is that it could lead us to more efficient post-training. Now, a lot of the compute that is being allocated for training language models is in the post-training. The biggest promise I see with discrete diffusion is post-training that is more efficient than autoregressive post-training. And I believe we will see that in the next 1-2 years.
Awesome. I think that's good. Yeah. Thank you so much for coming.
Thank you for the nice questions and having me.